So 4.3 starts on right triangle trigonometry, which you have already started learning about with the unit circle. Okay? The 6 trig functions are what we're going to focus on right now. So if I have a right triangle, some angle, okay, that we'll call theta. All right? The sine of that angle is going to equal what 2 side lengths divided? Who can tell me? Let's just review. Go, Trevor.
The opposite over the hypotenuse.
The opposite side over the hypotenuse side. Okay? The cosine of an angle will equal what 2 sides divided?
Adjacent over hypotenuse.
The adjacent side over the hypotenuse side.
And then
The tangent is equal to the opposite over the adjacent. Okay? Now let's go over the next 3 trig functions. 1 over the sine is the same thing as what trig functions? Anybody remember?
What?
1 over the sine is the same thing as what trig function? Cosecant. So the cosecant of an angle is going to be 1 over the sine value, which is also going to be flipping that fraction. So it's going to equal the hypotenuse side divided by the opposite side. Okay? The secant of theta.
Hypotenuse over adjacent.
Hypotenuse over adjacent. Good, because it's 1 over cosine. Hypotenuse over adjacent. Okay? And the cotangent of the angle is equal to what 2 sides divided?
adjacent over opposite.
Good. Adjacent over opposite. So how does this help us? Well, if I tell you that the cosecant of some angle is equal to 13 over 5, my question is, can you find the tangent of that angle? Let's talk about this. What is tangent of theta going to be equal to in that same triangle? That's where we're headed. Anybody want to take a stab at how to try to figure this out? Megan?
You would have to figure out what theta is in the cosecant first.
Okay, you could try to figure out what theta was. However, you don't actually need to do that. There's a way to do it without that. We don't need to figure out what the actual angle is. That's not what we're asked for. We're asked for the tangent of the angle. Other thoughts? We could go about it that way. I should be clear. You can do that. Okay? It's just going to take some time. Yep.
You already know what the cosecant is, so you already know the hypotenuse of the opposite side.
Okay, for tangent of an angle, I need the opposite and the adjacent side. So this thing comes from a triangle. All right? The opposite side, let's see, cosecant is the hypotenuse side divided by the opposite side, right? Okay, so let's say that this is my angle, and I'm aware that this might not be drawn to scale. However, I know that the hypotenuse has to be the 13. So the hypotenuse is always located on my triangle where? Yeah, it's always across from the right angle, okay? So this has to be 13, because that has to be the hypotenuse. The 5 has to be the opposite side to my angle, so I'll put 5 on this side, but just because that one looks shorter than this one does not necessarily mean that's true. However, can I find the adjacent side? I know tangent is equal to the opposite over the adjacent side lengths.
Yeah.
Okay, very good. The opposite side is still 5. The adjacent side we need to find by the Pythagorean theorem. That's a great idea. So 5 squared plus my missing side squared has to equal 13 squared. All right?
Let's get really quiet.
Yes, okay. The air turned off.
Okay, let's go scary.
So 25 plus x squared equals 169. Subtract 25 from both sides and I get 144. X squared equals 144. So x equals 12. So my adjacent side is 12. So my tangent of my angle is equal to 5/12. So you did all that without actually finding the angle. Does that make sense? You can find the angle. There's nothing wrong with it. However, you can relate these trig functions to each other by just knowing one of the trig functions. You can actually find all 5 others by the Pythagorean theorem.
Third.
All right. Do we have questions so far? Okay. Can I erase the board? So far, so good? You're going to need these 6 trig functions. You have them written down now. Do you want me to leave these up here at all?
I don't think so. I'm good.
Can I erase them?
They are in the blue.
You can take a picture. Sure. Go for it. Yep. You want me to erase the example so that it's not in your white?
That's fine, I can work around it.
I remember
If anything,
this.
the example helps, is I've got one there that's worked out for it.
Is this like... Never mind. This is the only thing I'm good at.
I doubt that.
I'm not lying to you.
We practically just learned this in physics.
Yeah, we did, like a week ago.
Yep.
So that's kind of great. Yeah, we just learned.
All the photographers in here, tell me when you're done. Got it?
Can you just go straight across?
Okay, thank you.
All right. So here are some examples of when we might use this. The instructions could be, find the 6 trig functions of the angle. Okay? Here's a triangle. Not drawn to scale, but that angle is a right angle because I'm putting a box in it. Okay? So 4 is the hypotenuse, and 2 is that side right there, and this is called theta. Find the exact value of the 6 trig functions of theta. Okay? So I really need sine theta, cosine theta, tangent theta. I need to find cosecant theta, secant of theta, and cotangent of theta. All right. So let's see. My angle is marked right here. I have 2 and 4. What's the sine of theta going to equal?
2. I meant 1/2.
1/2 I would go with.
Yeah.
Okay, because the sine of theta is going to be 2 over 4. It's the opposite side divided by the hypotenuse side. Okay, and the opposite side to your angle is 2, and the hypotenuse is always the one across from the right angle. So 2 over 4 reduces to 1/2. That's the sine of my angle. What's the cosine of my angle going to be?
Yeah.
We need to find the adjacent side length, so I should probably call that x. 2 squared plus x squared equals 4 squared. That's the Pythagorean theorem in use. A squared plus b squared equals c squared. Okay, A and B are always your shorter sides, and C is always your hypotenuse. So that gives me 4 plus x squared equals 16. So x squared equals 12. X equals the square root of 12, and I should probably simplify that. I would like the exact values, so do not come up with a decimal at this point.
2 square root of 3.
Oh, good. You remember how to simplify square roots. Let's review that for people that may need it. Square root of 12, factors to be 4 times 3. 4 is 2 squared, okay? So the square root of 2 squared and the square root of 3, when I teach it in Algebra 1, I say couples of factors go out and singles factors stay in, kind of opposite of real life. So this is going to be, that can actually be square rooted as 2, okay? Square root of 3. So 2 square root of 3 is my x. All right, so adjacent over hypotenuse is going to be 2 square root of 3 over 4, which is what?
Square root of 3 over 2.
Good, square root of 3 over 2. Why are these answers sounding familiar? Ah, we just did this on the unit circle. You come up with a cosine value of square root of 3 over 2 sometimes. You come up with a sine value of 1/2 sometimes. We need to think maybe about what angle gave us those after we finish the rest of this problem. So tangent of theta will be what?
2 over 2 square root of 3.
Okay, we opposite over adjacent, so 2 over 2 square root of 3 is going to be 1 over the square root of 3, but that's not simplified.
Square root of 3 over 3.
Square root of 3 over 3 is the simplified tangent value. I should have left myself a little more space. Sorry about that. All right, the cosecant value. Anybody want to give me the cosecant value?
What did we do? 4 over 2.
4 over 2, okay, or just flip the sign value, right?
Yeah.
So 2 over 1, or just 2. Okay, what about the secant value of my angle?
4 over 2 square root of 3.
4 over 2 square root of 3. Okay, right here, just flip that. You can actually flip the reduced form instead if you'd like. So 2 over the square root of 3. But if I get 2 over the square root of 3, that's not simplified, because again, I get a square root in the denominator, so I need to fix it. Go ahead, Ben.
2 times the square root of 3 over 3.
Good. Okay, so if we multiply top and bottom by the square root of 3, we will rationalize the denominator and get rid of the square root. All right, so that gives me 2 square root of 3 over 3. That's fine. How about the cotangent of theta?
2 square root of 3 over 2. So square root of 3.
Yeah.
Good. I can flip any of these forms. It doesn't matter which one. Why not just flip the one that has a 1 on top so that when it flips, it goes onto the bottom? So square root of 3 over 1, or just square root of 3. If you start with any of the other ones, that's fine. You'll just have to rationalize the denominator. You should come up with the same answer after you simplify. Are we good with these? Okay. By the way, what was our angle measure?
45.
Not 45. 45 has sine of square root of 2 over 2, cosine square root of 2 over 2. Remember, pi over 4.
It was 30, or something like 30.
Pi over 6.
Pi over,
6.
that's square root of 2
Pi
over 2.
6. Pi over 6.
Pi over 6.
Yeah,
One
that's
time.
what I've been saying.
I disagree with that.
30.
Oh.
sine x would be, or y would be.
Pi over 6 is right here. The sine value and the cosine value. Let's see, my sine value is a half, my cosine value is square root of 3 over 2. My ordered pair goes in what order?
Square root of 3 over 2, 1/2.
Okay, and is that correct for what I have, what information I have over here?
Yes.
Square root of 3 over 2 is my cosine value. Is cosine first in my ordered pair?
Yeah.
So yeah, pi over 6 is my angle that gave me those. So actually, these are the 6 trig functions for pi over 6. We didn't need that to find our trig function values, but it's possible to find what it is because we know the unit circle. Good job. Okay. Are we all right with these? Questions? Thoughts? Comments? Yeah, hang on just a minute. Okay, so we're good with this? Okay. Stop. Stop. How do you get it to stop?
I'll show you.